Welcome back. This should be our video 5. This should be our video 5. Resistors in parallel. When two or more resistors are in parallel, their ends are like joined together to the same point. Their ends are like joined together to the same point. So if this is R1, this is R2, this is R3, current I1 will go through this, current I2 will go through this, current I3 will go through that. But the same voltage will be across them. The same voltage will be across them. Because they are connected across the same point. Don't worry the way I draw it. If you draw them like this, sorry for my pidgin English, if you draw them like this, now the same thing. Now the same thing. You understand me? So the idea is that they are joined to the same point. This one eventually is coming to this point. This one is coming to this point, just like this. So it's the same thing. So since they are connected, a voltage, a potential, a PD, potential drop, PD, is always across 2 points. You understand me? And since they are connected between the same 2 points, they have, so, but the current coming, we have to divide. I can say this is the current coming, or let me say this is the I total current coming in. It will be divided among them. Now, we can write that V is equal to I1 R1. The same V is equal to I2 R2. The same V is equal to I3 R3. We can say that I total equals to I1 plus I2 plus I3. If that is the case, from here, I total is going to be equal to I1 will have been V over R1, I2 from here will have been V over R2, I3 from here will have been V over R3. Suppose I have a single resistor. Suppose I have a single resistor connected across, let me say this is equivalent resistance, RE. This is equivalent resistance, RE. And the same voltage, V, will be across it. And the same total current will be across it. So in that case, I can say that IT is going to be equal to what? I can say that V is going to be equal to IT RE. And from here, IT is going to be equal to V over RE. If I compare this with that, that means V over RE is going to be V over R1 plus V over R2 plus V over R3. Divide through by V. Divide through by V. This will give me that 1 over RE is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3. Conclusion. In the case of parallel, resistors in parallel, equivalent resistance is such that 1 over equivalent resistance is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3. If you have 7 resistors in parallel, that will be 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R7, like that. So this is equivalent resistance. When we say equivalent, it means this single can replace the whole of this. So when we are in the circuit, when we have these three, we can replace it with RE. Now, let's consider a situation where we have only two. Let's consider a situation where we have only two. Let's consider a situation where we have only 2. If I have only 2 resistors in parallel, many can be in parallel though. Many can be in parallel. I want to consider a special situation where I have 2 R2. It means 1 over RE is going to be equal to 1 over R1 plus 1 over R2. Now, take the LCM. This will be R1, R2. This will be R2 plus R1 equals 1 over RE. Turn both sides upside down. RE is going to be equal to R1, R2, R1 plus R2. Which means when you have 2 resistors in parallel, to get the equivalent resistance, multiply them on top, add them below. That's the equivalent resistance. For 3, when we add 3, I cannot do it like that. You understand me? For 3, what will I do? I will find 1 over R1. I will add it to 1 over R2. I will add it to 1 over R3. The sum I got, that's the reciprocal. I have to reciprocal it again to get that. You get my point? Okay, let's give you an example. Suppose I have 2 ohm, I have 4 ohm and 2 ohm in parallel. For this will be what? 4 times 2 over 4 plus 2. This is 8 over 6. This is like 4 over 3 ohm. If I have 4, 3, 2 in parallel, 3 now, not 2. So 1 over RE is going to be equal to 1 over 4, 1 over 3 plus 1 over 2. SCM is what? 12. This will be 3 plus 4 plus 6. Am I right? So this will be equal to 13 over 12. What would then be RE? You have to somersault that one. That would be what? 12 over 13. For 2, makes it easier. Just product them on top, add them below. That's easy. But for 3 and more, you have to first do the reciprocal, add, and reciprocal again. Now that takes me to the subject of current divide ratio. Let me now consider current divide ratio. Remember, in one of the previous videos, we talked about voltage divide ratio when they are in series. So when they are in series, we talk of voltage divide ratio. When they are in parallel, we talk of what? Current divide ratio. Current divide ratio. Current divide ratio. So if I have 2 resistors if this is R1, R2, this is the I total. This is I1, and this is I2. Now, so you know this is V, the same voltage across there. You know that V is going to be equal to I1, R1. The same V is going to be equal to I2, R2. And if that is the case, also from here now, I know that IT is going to be equal to I1 plus I2. We know that, Abi? So from here, I1 is actually V over R1. V over R1. I2 is V over R1, R2. Then, but you remember that the equivalent resistance is R1, R2 over R1 plus R2. And remember that, you also remember that V is also equal to IT multiplied by RE. So from here, what are we saying here? From here, we can see that V From here we can see that IT is equal to V over RE is equal to V R1 R2 over R1 plus R2. This is equal to V R1 plus R2 over R1 R2. You know that this RE is something over something. When you have something over something over something, this one can jump up. You have noticed that in mathematics. So from here now, I can say that V equals R1, R2, R1 plus R2 into IT. Because this is IT, make V the subject of the formula. Make V the subject of the formula. V will now be R1 and R2 will come on top here, and then R1 plus R2 will come below. Let's now come here. Let's come here now. Substitute for V. If you substitute for V, we say that I1 is going to be equal to V is what? R1, R2, R1 plus R2, IT. And we are to divide by what? R1. We are to divide by what? R1. So this R1 will cancel that R1. So I1 is going to be equal to R2 over R1 plus R2 multiplied by IT. So the current divide ratio is going to be, if you need the current in R1, you take the other resistance, divide by the total resistance, multiply by the current you want to divide. For I2 is going to be V over R2. V is what? R1, R2, R1 plus R2, IT, divide by R2. So R2 will cancel R2. So I2 is going to be equal to R1 over R1 plus R2 multiplied by IT. This is referred to as current divide ratio. Current divide ratio. Well, if you need the current in a particular resistor, you take the other resistor, divide by the total resistances, multiply by the current you want to divide. Let's give an example. Suppose this is 4 ohm and this is 2 ohms, and the current we want to divide is 10 ampere. Let's see how it will be divided. For I1, we are going to take the other resistance, which is 2, over the total is 6. We are going to multiply by the current we want to divide, which is 10. So this is like what? This is like 2 over 6. This is like 20 over 6 ampere. You can find the binary value. You understand me? For the other one, for I2 is going to be what? The other resistance, which is 4, over the total multiplied by 10. That would be 40 over 6 ampere. So this current divide ratio. That means the one with higher resistance will take a lower current. The one with lower resistance will take higher current. You understand? Where there is little resistance, more current will flow. Where there is more resistance, less current will flow. I think we can stop this video 5 here because of space. Thank you very much. I hope you enjoyed this thing.